Hey, Geometry for Teacher students. We've got a problem here where we've got 3 points and we want to show that they're collinear. That is, they line up in a straight line, and we're going to use two different techniques. Now, when you're doing the distance formula, it's really important to make sure you know which point is in the middle out of your 3. And we can do that by looking at our x-coordinates, 1, 3, 7. So Q is in the middle. All right, so we're going to start finding distances. So let's find the distance from P to Q. So we're going to use our distance formula, which is that big square root. We want 3 minus 1 squared. That's the difference in the x-coordinates. And then minus 2 minus 3 squared. So that's going to be the square root of 4 plus 25. That will be the square root of 29. We're going to keep on doing that. So now we're going to talk about Q and R. So we're going to have 7 minus 3 squared. Again, that's the difference in the x-coordinates. Plus negative 12 minus a negative 2. We're going to flip the sign there since we're subtracting a negative. And we will get the square root of 16 plus 100. So that's the square root of 116. One last time. Now notice that we used these 2 points and these 2 points. Now we're using our outside points. Now we're getting to the big numbers. What are we getting? 36 plus 225 is the square root of 261. Now, let's pause right here. What you'd like to show is that this number plus that number equals that number. And you can plug that into a calculator and you'll see that works. You can also see it this way. So this is going to be the square root of 4 times 29. So that is 2 times the square root of 29. Sorry, that's cramped. This is the square root of 9 times 29. You can factor out a 29. This is equal to 3 times the square root of 29. So what we need is that PQ plus QR equals PR. And we can check square root of 29 plus twice the square root of 29 equals 3 times the square root of 29. Check, collinear. So that's how to do this using the distance formula. And again, if you didn't see how to simplify these square roots, you could just take this number in a calculator plus that number in a calculator, and you should get that number in a calculator. Let's erase what we have here. And let's do this using slopes. So with slopes, we want our two slopes of our line segments from P to Q and from Q to R to be equal. So slope from P to Q. So we want the difference in the y-coordinates, minus 2 minus 3, over the difference in the x-coordinates, 3 minus 1. Look there, there's a y, negative 2, it goes with that, x, positive 3. And there's 3, it goes with 1. What do we get here? Negative 5 halves. All right, let's do the slope from Q to R. So we have minus 12 minus a negative 2 over 7 minus 3. Again, notice how I'm lining up points here. Y is on the top, x is on the bottom. We get negative 10 over 4, which simplifies to negative 5 halves. Those slopes are equal. Check. So that's another example of why we know that these 3 points are collinear. So there's our two methods, the distance formula and slopes.